Okay, everyone. I had to cut that other video short. Let's go right to number 13. So 13, this 4 here is telling me the entire function is being raised to the fourth power. So before I find the derivative, I'm just going to write this in more of a user-friendly term. Give myself a little more room here. Okay, actually make this a little bit thinner. Okay. And so this is going to be cotangent of x over 2 or 1/2 x, the whole thing raised to the fourth power. That's really what that's saying. So yes, I'm going to have to use the chain rule twice. Once here and once for what's inside here. Okay, so y prime equals 4 times whatever's inside here, unchanged, cotangent of x over 2 raised to the third power, because I'm knocking it down one, times the derivative of what's in here, so the derivative of cotangent, and the derivative of cotangent is, let's see, negative cosecant. So it's negative cosecant squared, negative cosecant squared of x over 2, and now we're going to find the derivative of what's in here, because it's not x. The derivative is not 1. It's something else, so we have to include it. And the derivative of this, well, this is just really 1/2 times x. So the derivative of 1/2 times x is just 1/2. And I'm going to put the 1/2 down here, because I ran out of room. And I'm done. So I'm going to put this all together now. And let me just highlight a few things for you. So this 4 is on the outside, and this 1/2 is on the outside. And this negative sign, I'm going to put that on the outside because that's just cosecant squared being multiplied by negative 1. So 4 times negative 1 is negative 4. Half of that is negative 2. So my answer is going to be negative 2 times, let's see if I can fit this all in one line. I'm going to be careful. Times cotangent of x over 2, the whole thing being, you know what, and I'm actually going to, hold on. I'm going to put it to the third power the way textbooks would. So that's a 3, everyone. Cotangent cubed of x over 2 times, remember we already put the negative in the front, cosecant squared of x over 2. And that's it. We're done. Okay, let's move on to number 14. Okay. Let's see, for number 14, I'm going to go ahead and use the quotient rule. So this is a fraction, this is a ratio, so I'm going to use the quotient rule. And it's an even number, so we're going to do it in blue. All right. So let's, I'm just going to put a little reminder, quotient rule. Okay, here we go. And what is the quotient rule? It's d high times low, so the derivative of the numerator, which is cosine of x times the denominator, minus, and the derivative of the denominator. So the derivative of the denominator, we're going to have to use the chain rule. So derivative of 1 is 0. I'm not going to bother writing that. And the derivative of cosine squared of x is 2 cosine of x times negative sine of x. And then the chain rule, what is the derivative of x? 1, so we don't have to write that. So it's the derivative of the denominator times the numerator. And this whole thing is part of the numerator. I'm sure your notebook is wider than my iPad, so this should all fit in one line. And the whole thing is over 1 plus cosine squared of x squared. All right, I'm going to try and clean this up a little bit. Okay. Let's see here. So if I distribute this, let me take a look at it. Is this going to really clean this up? Well, nothing's really going to clean this up too much. I am noticing that I can factor out. Here, let me go ahead and distribute because I know a lot of you are going to want to do that. So cosine of x, so I'm going to distribute this times 1 plus cosine Now it's cubed, right? Because it's cosine, 1 cosine times cosine squared. Minus, let's see, 2 cosine of x times negative sine of x. So that's actually positive 2 cosine of x sine of x. Let's see, 2 cosine of x sine, and it's actually sine squared because there's 2 sine. So I just multiplied 2 times cosine of x times negative sine of x times sine of x. But since this is negative and I'm subtracting, a negative times a negative is a positive, and that's where this plus came from. Okay? And the whole thing is over 1 plus cosine squared. The only other thing you can do is, if you'd like, is I would factor out a cosine, because if yeah, you can factor out a cosine here, since there's a cosine here, a cosine here, and a cosine here, just to clean that up a little bit. I ran out of room, so I'm not going to do it now. But that's all. Other than factoring out a cosine, cosine of x, there's nothing else you can do. Okay, let's do number 15. This is going to be maybe the last one. Let me change colors, red. Okay. And notice here, instead of sine of x, it's sine of another trig function. But we're going to treat this as if this were x, or x plus 2. The same thing. This is here just to stump you, but if you know the rules, you're doing the same thing. Okay. So let's get started. So y prime equals, again, let me stress, you are not using the product rule because it's the sine of cosine of x, not the sine of x times cosine of x. If this were the product rule, I'd have an x here. But here, the cosine of x is what's being applied to the trig function. So I just want to emphasize that so you guys can wrap your heads around it. Okay, so the derivative of sine is cosine. Whoops. So cosine of x times the derivative of what's in here, since it's not 1, and that's negative sine of x, times the derivative of x, which is 1, so I'm not going to write it. And we're done. So your final answer is y prime equals, let's see, I'm going to put the sign in the front only because of the negative. Let me erase that. And it's going to be, whoop, negative sine of x times cosine of x. There is no x in front of this cosine because this is what's being applied to this trig function. And that's it. We're done with that one. Let's see if we can squeeze in one more. Okay. Number 16. Where are you, number 16? On the bottom over here. Okay. So for number 16, we are being asked to find the equation of the tangent line. And we had this on the test last week. So you're finding the derivative. That derivative is the slope. You're evaluating the slope at whatever x value you're given, and here it's 0. And then you're constructing the line from this ordered pair. So let's see here. Y prime equals, again, this is going to be the product rule. So the derivative of sine of x is cosine, so it's going to be cosine of x times cosine of x plus the derivative of this now, plus negative sine of x times this sine of x. Okay, and that's going to give me y prime is cosine squared of x minus sine squared of x Okay, so this is what's going to give me my slope now that I'm done with the derivative. And again, let me emphasize, we're not using the chain rule for what's inside because, well, we can, but the derivative of x is just 1, so it's unnecessary. Okay, so now let's apply or evaluate the x value that we're given. So the cosine squared of 0 minus the sine squared of 0. Well, cosine squared of 0 is 1 because the cosine of 0 is 1 and 1 squared is 1. And the sine of 0 is 0 and 0 squared is 0. So my slope is 1. And I'm going to go ahead and now I think all of us kind of automatically go to this, okay, it's 1x plus b. But take a look at the ordered pair we're given. We're given 0, 0. We're actually given the y-intercept. We're given b, and it's 0. So your final answer, the equation of the tangent line for this graph is y equals x. Done. Okay, we're almost done here. Let's go right to number 17. And here we're going to have to use the quotient rule. So let's see, y prime equals d high, which is 2 times cosine of x minus, I'll put brackets here. I like to put brackets because it reminds me to distribute that negative sign, minus the derivative of cosine, which is negative sine of x, times the numerator, which is 2x, and the whole thing is over cosine squared of x. And I'm not going to worry too much about simplifying because we're going to evaluate it at a value anyway, at a number anyway. All right, so that's my slope. So the slope is going to be 2 times the cosine of 0. So wherever there's an x, I'm going to evaluate it at 0. Let's see, plus, because minus a minus, so plus the sine of 0 times 2 times 0. Well, that made that easy for us. And the whole thing over cosine squared of 0. So that slope is, well, I know that the cosine of 0 is 1. So 2 times 1 is 2. And the sine of 0 is 0. And 2 times 0 is 0. So 0 times 0 is 0 anyway. So it's 2 over. And again, the cosine of 0 is 1. And 1 squared is 1. So the slope is 2. And again, I'm going to go back to my ordered pair that's given. And they gave me the y-intercept. So I'm not going to go through all that rigmarole to try to find b. It's given to me. So y equals 2x. You're done. All right, last one. Number 18. All right, this one's a good one. If you really understand this, you should be able to do this. Okay, so notice here, this is the sine of x times sine of x and cosine. It's not the sine of this, like for number 12, let's say, or number 15. I can distribute this. You don't have to, I'm going to. All right, so we're going to go back to blue. Let me see. Yep. Okay. So I'm going to go ahead and distribute this before I do anything else. So y equals sine squared of x. I'm just distributing. Plus sine x cosine x. Okay, so now I'm going to go ahead and find the derivative. So y prime equals, well, for this first term, it's going to be 2 times the sine of x, and then the derivative of what's inside the parentheses. So that's going to be times cosine of x, and the derivative of x is 1. I'm not writing that down. Just a little footnote, everybody. I kind of went a little quickly. I did not write it like this, but that's really how it should be written. But I figured we've been doing this for the other problems, so I just wanted to plunge right in. So that's why it's 2 times whatever's inside the parentheses, knocked down 1, times the derivative of what's in here. So that's why that's like that. So let me go ahead and erase that. Okay. Plus, and we're going to have to do the product rule here. So the derivative of sine is cosine. So let me put brackets around this. So the cosine of x times the cosine of x plus, now the derivative of cosine times sine. Well, the derivative of cosine is negative sine of x times sine of x. And let's clean this up a little bit. Y prime equals 2 sine of x cosine of x plus cosine squared of x minus sine squared of x. And they want us applying this. So this here is our slope. And we just have to get a numeric value, we're going to have to apply pi over 4. So let's see. The slope equals 2 times the sine of pi over 4. And by the way, that's root 2 over 2. And, we're running out of room, so I'm just going to go ahead and apply. So I know that I know that if I put a pi over 4 here, I know the sine of pi over 4 is root 2 over 2. And I know that the cosine is root 2 over 2. So this whole thing is going to be 2 times root 2 over 2 times root 2 over 2. That's just this part here that I've highlighted. So if I multiply that out, so the square root of 2 times the square root of 2 is 2. So there's a lot of 2's here. So 2 times, that's the outside 2, times 2 over 4. So that's 2 times 1/2 if I reduce this, and 2 times 1/2 is 1. So this whole thing ended up being just 1. So I'm going to erase all this to save room. And this whole part I've highlighted equals 1. Okay, so let me erase. Let's see. All right, so let me get a different color highlighter here. Okay, so now I'm going to apply pi over 4 here and pi over 4 here. So plus, again, the cosine of pi over 4 is root 2 over 2. And remember, I'm squaring it. So root 2 over 2 times root 2 over 2 is 2 over 4, or 1/2. Minus, and it's the same thing for sine squared because it's the same value, minus 1/2. So let's see here. My slope equals 1, right? Because positive 1/2 and minus 1/2 cancel out. So my slope is 1. All right, so I'm going to erase some of this now so I have time to actually, I have room to go ahead and finish the equation of the line. So the other ones we got lucky because the y-intercept was given to us, because the x value was 0, so whatever the y value was the y-intercept, which happened to be 0. Well, for number 18, they want us to work for it. So again, m equals 1. And here you could use point slope form if you want. So might be easier this time. So y minus 1 equals the slope, which is 1, times x minus pi over 4. Much easier than finding the y-intercept here. That's why I like point slope form, because when you don't know the y-intercept,